welcome to the last day of our ZVM training. Congratulations to all of those who have made it this far. Just a reminder that this is being recorded and will be uploaded to our website, and all questions should be typed into the chat box or emailed to questions@velocitysoftware.com. Up first, we have Rich Smersna with Intro to REXX. Rich has decades and decades and decades of ZVM experience and has been with Velocity for over 16 years. He loves traveling to new places. Go ahead, Rich.
Thank you very much, Sam. I wonder who wrote that. Um, Thank you all for joining. I'm going to talk about REXX. So we're going to talk hopefully very thoroughly about how REXX works, what it is, how to use it. Feel free to follow along on your systems, whether you're on our VM system or your own. You can certainly use use those systems to try out some of these code snippets that I'm going to have in this presentation. Here's a little overview of what I'm going to cover. There's probably a lot more here that I'm going to cover, but this is just a quick example.
Rich.
Hey, Rich, you're not sharing.
Oh, I was. What happened to my share? Let's try this again. How's that?
That is better.
All right. I thought I was sharing. Okay, moving on. This is, we're going to talk about some syntax style, how functions work, arguments, passing arguments to functions and to REXX itself, and some parsing, and there's probably a lot more that's going to get covered here that I didn't put in this overview. There are a lot of reference materials available. The REXX User's Guide and REXX Reference on the IBM website, those are very helpful since they talk specifically about REXX for CMS. There's a training program that IBM provides about REXX. The REXX Language Association is also a very good reference. And there are two open source projects, Open Object REXX and Regina REXX, that you can use on Windows or Linux that allow you to exercise your REXX skills on those platforms. REXX stands for Restructured Extended Executor. It is an interpreted language. There is a compiler, but it is very rarely used because if you're going to compile the code, you need the compiler runtime in order to use it. If you don't have the compiler runtime, it just acts as an interpreted language. It is also a typeless language, meaning you do not have to declare what your variables are used for before you use them. You don't have to tell it it's pick X or a character or a decimal value. REXX kind of figures it out and does a pretty good job. It runs on a lot of different platforms, including all the mainframe platforms, in addition to Linux and Windows. The REXX Language Association has a page that talks about the history of REXX. So this is a very good reference if you want to learn how REXX came about, how it was developed, and a lot of other information on the REXX Language Association about REXX in general. So this is a good reference if you want to get that history information. All right, starting off, REXX programs running in CMS must have a file type of exec. Now, we learned about file types in the past couple of days, and we were talking about CMS. That is the middle component of the file ID or the file identifier. And there are some exceptions. We're not going to talk about those exceptions, but generally, if you're running a REXX program, it has a file type of exec. REXX programs must also begin with a comment. A comment is delineated by a slash asterisk asterisk slash set of characters. Anything in between those is considered a comment. On CMS, the comment can be a blank, a null comment. So you can have just the term delineating characters with nothing in between them. That is perfectly fine. On some platforms, a comment is required, and some of them even require specifically REXX as the comment, but not in CMS. Just a null comment is perfectly fine. REXX clauses are typically delimited by a new line. A clause is a statement. So an assignment like these two, A equals cat, B equals dog, those are considered clauses. And and they can appear on separate lines on the screen. They can also, in the file, I should say, they can also be delimited by a semicolon on the same line. So if you want to string out a set of clauses, you can do so, but separate them by semicolons. A semicolon at the end of the line is perfectly acceptable. Some languages require it. REXX does not. A clause can be an assignment, like in this case, A equals fish. It can be a label, which is a branch point in the program. It could be a host command, which is a command that is being issued to the host environment, a null line, a blank line, or other REXX instructions, in this case, a signal instruction. Style of how you code REXX falls under generally coding standards, and it can vary based on who basically who's in charge of programming at the time. Generally, what we suggest is you pick a style and stick with it. So if it is something you like, if it's something that works for you to help you understand the code better, just stick with it. In our case, we tend to use these four style options: variables in lowercase, labels in uppercase, host commands in uppercase enclosed in quotes or double quotes, and REXX clauses and keywords should have the first character capitalized. That's generally how we write our program. So the examples here below show how those various style elements would work in a program. Indentation is not required in REXX, but it is helpful to allow humans to read the program better. So help yourself and help someone else who might be coming to maintain your program in the future by indenting correctly or properly. Usually the indentation is 2 characters or spaces. A do block and select block, which we'll talk about later, should have the same indentation, and anything in the do block or select block should also be indented. And we also indent clauses for an if structure. So in the case below here, we see on line 3, we have an if clause, and what is under the if is indented, and under the else clause, the do block is indented, and the contents of the do block are also indented. That's what we mean by indentation. Very easy to read and follow if you follow consistent indentation and style rules. All right, a variable is defined by a name. A variable that does not have a name is its name in uppercase. So if we have a variable called name and it is not assigned, it just contains the value name in uppercase. An initialized variable has the value of what it was assigned to. So in this case, Andrew is assigned to name and would be used as the value Andrew in the program. It is always a good practice to initialize variables to avoid any errors in the program later. And you do that by with double quote double quotes or single quotes together, creating a null value, or zero if it's a numeric, if the variable is used as a numeric. So this is a short quiz that we're just going to do via the chat, responses in the chat. So what we have here is this short program snippet, and we're assigning three variables to various values. And what we want to have you do is indicate what the value is going to be when the say clause, which will display the contents of the variable, is executed. So what would name one be? And hopefully there's a lot of smart people monitoring the chat and looking at these answers. Yep, I'm seeing some answers come in. Good job. Yep, it is Sam with S capitalized because it is a literal value inside quotes. Good job. The next one, name two, what would it be? I'll wait a few seconds for the results. Yep, I'm seeing a lot of them come in through the chat. It would be a null value because the name two is being initialized to null. Name three, what would name three be? Remember the rules for variables that aren't assigned. Good job. Some of you are getting it. It is Sam in uppercase because Sam is not assigned in the program, and the value by itself, the value is translated to uppercase. And the next one, what would the next one be? For those of you that said name four in uppercase, yes, exactly right, because name four is not assigned in the assignment section. Good job, everybody. Okay, quotes can be used to delineate a string of characters, and you can use either a single quote or a double quote. But you have to be consistent. You can't start a string with a single quote and end it with a double quote. REXX will get very confused, or vice versa. So if you like the double quotes, consistently use double quotes. If you like single quotes, use single quotes. The caveat here is if the string contains that type of quote, you have to use the other type of quote. So in this case, we had to use double quotes because there is an apostrophe character, which is a single quote inside the string. The next example just displays the string in uppercase because REXX thinks these are all variables, and since they wouldn't be assigned, it would translate the whole string to uppercase. You can use vertical bars to concatenate string values together. In this case, we are concatenating individual characters, but this can very easily be used to concatenate longer string values. So in this case, I am concatenating capital C, capital A, capital T, and the vertical bar symbols in between them just pushes them all together to create the word cat. Concatenated hex values have to have a space after them. So if we use the say clause with C3 and a X after it, this indicates that the value is a hex value and it's going to display the letter C, since C3 is the EBCDIC C. If you try to concatenate it with AT, it's not going to work because REXX just thinks it's a string of characters and will just display that string of characters. You have to do a concatenation in order to get the right results that you'd be looking for. Compound variables are known as stems. Traditionally, in traditional languages, they're arrays. So a compound variable or a stem, it's basically the same thing, and it's an array of values. So in this case, we are assigning day.1 to Monday. 1 is the stem part of the variable. Day.2 is going to be Tuesday. Further on, if we assign the value 1 to the num variable and say day.num, it's going to produce Monday because num is the num variable is resolved first before day.num is resolved. To initialize the entire set of compound variables, just assign the whole thing day dot to a null value. And that is usually a good idea when you're using a set of compound variables. Initialize it before you use it so you don't run into any problems. STEM references need to be numbers or variables. So data today is perfectly valid. Data today, the today variable, does not have to be set. It can just be a term that you're using to reference what day today is. And you can initialize it to a value and use it in the program just like you would any other STEM variable. And just like day.1 equals Monday. So the STEM value does not have to be a numeric value or even resolve to a numeric value. It can be a word. References to a function in a STEM variable will fail. This would be quite handy, but it doesn't work in REXX. So I can't, even though date num might resolve to a numeric value, I cannot use it in a STEM variable. Okay, quiz time. Sam, you ready?
Yep, Slido is up. You guys should be able to start joining now.
All right, a REXX program must always start with what? Oops, I kind of jumped the gun there.
Just a little bit.
That's all right. Hope I got them all right. Woohoo! All right. Good job, everybody. Thank you for participating. All right. The say instruction or clause will write the subsequent values or expressions out on the console on the display device, right? So if we're going to do say hello there, and hello there is a literal since it is enclosed in double quotes or quotes in general, and your name will be displayed after it, assuming your name is initialized as a variable. Otherwise, it would just say hello there, and your name will be in capital letters. The literal your name, since it's not initialized. We can also, we can also put an expression on the say statement. So if we want to multiply 3 by 5, for instance, we can put 3 asterisk 5 as part of the say statement, and REXX will very happily calculate the result and display the value for you. arg gets its values from the command line that are passed to the exec. So if you're writing an exec and you want to vary the response of the exec or vary the flow of the exec based on arguments that you pass to it, you can do so right on the REXX command line. And the arg statement takes one or more variable values. The command line arguments are translated to uppercase. Each word in the command line that is assigned to a symbol or variable in the list. If there are too many arguments, the last symbol contains the remainder of the parameter list. If there are too few arguments, unused symbols are set to null. And you can use parse arg to respect mixed case values. And here are some examples. So in this first example on the upper left, we have an exec that is going to accept 3 arguments, and I'm just going to display those arguments on the console. So here I'm running the exec, it's called examp3, and I'm passing 2 values, mine and yours. Variable 1 displays mine in uppercase because argument translates the results to uppercase. Variable 2 contains yours, and variable 3 contains nothing since the third argument was not passed. In the next example, I'm passing 4 arguments. The first 2 work as before, but the third one contains the remainder of the argument string because there was no 4th argument assigned. So it's going to contain everything else. On the bottom, we have an example of parse arg. It works very similarly, except that the results, what is passed to the program, has the case maintained. Poll will read values from the console or the program stack. We're going to talk about program stack in the next REXX course later this month. But poll works like arg. Each word entered from the console and on the program stack is assigned to a symbol or a variable. And you can use parse poll to respect mixed case values, just like you can with parse arg. So the example here on the left, very similarly, if we run the example, examp4, what you don't see here is the fact that the console is presenting, excuse me, has a VM read on the bottom right, which means that the program is expecting some kind of input. And at this point, you can enter your values and it will display the values very similarly to how arg works. And now we have another quiz.
All right, Slido's up. Go ahead and hit join. Go ahead, Rich, with the answers.
Thank you, Sam. And here are the answers. arg gets its values from the command line. Poll gets its values from the console or program stack. And the keyword used to preserve case is parse. Good job, everybody. Thank you. Thank you, Sam. If then else allows you to evaluate a condition, an expression in your REXX program. And the expression is evaluated. If it is true, instruction 1 is executed. If it is false, the else condition, instruction 2 is executed. Instructions can be a no-op, so there are situations where you may not want to do anything if the condition is true or false. You can just specify no-op. A do block is required if you have more than one instruction to execute. So if you need to do multiple issue multiple REXX commands, clauses inside of as a result of a condition, a do block is required. You can also nest if structures, and that is also allowed. So in this case, on the right-hand side, I'm assigning variables with 2 numbers, num1, num2. If they are equal, I display equal. If they are not, I display not equal. I would expect the result to be not equal since the numbers are clearly not equal. So that's how if works. There are arithmetic operations available as well in REXX, and those are listed here. Some of the more interesting runs are here on the bottom: integer divide, remainder divide, which are very helpful short ways to get either the integer component of a division or the remainder from a division. All very powerful. There are also comparison operators available. There are a lot more comparison operators than I can list here, but the idea is that traditional comparison operators are available in the REXX language. For not equal, we tend to stay away from the last three, the caret equal, the backslash equal, and the logical not equal, because they don't translate well between code pages. So we stick with the first two, you should be pretty safe. Do loops allow you to perform an operation multiple times based on a condition. The condition is evaluated. If the condition is true, the instructions are executed inside the loop. If it is false, the loop is skipped entirely. Additionally, there is a do forever function that or capability that allows you to execute the loop until it is told to terminate. If there is no termination of the loop, then your virtual machine is pretty much stuck, and you have to use the halt execution function or re-IPL your virtual machine. There is also a do until and a do while. A do until will evaluate the expression at the end of the loop, which means the loop always executes once. A do while evaluates the expression at the top of the loop. And if it is false, the loop will not execute at all. I see a question in the chat came up about strictly equal. Yes, I was going to discuss this. Strictly equal means is going to do a comparison based on the length of the string. So if you have a string with no spaces at the end of it and a string with spaces at the end of it, strictly equal, if they're the same characters inside, even strictly equal will flag those as not equal because the length is different. That's what strictly equal provides for. Here are some examples of a do loop. So the do I equals 1 to 10. I is a loop control variable. And what you're doing here is we are incrementing the value of I by 1 each time through the loop. So this is very similar to how the for loop in C works. And inside the loop, we are displaying the value of the control variable and the word cat. So just as you would expect, we're going to get 10 lines of output with the count 1 through 10 and the values cat. In the next example, we are going to do forever and just write out cats. And what's going to happen is, since there is no programmatic way that we are executing this loop, it is just going to run and run and run until you use the HX function in which will halt execution or IPL your virtual machine. On the right-hand side, this is sort of an impromptu quiz. We're going to do I 1 to 10 by 2 and then say cat. Now, this first example, if you don't have by on the do command, it's going to assume 1, which means it will iterate that many 10 times through the loop, counting from 1 to 10. In this case, what do we think it's going to do? How many cats are going to be displayed? You can put it in the chat. All right, good job. Yep, it is 5 cats. So we're going to see 5 cats on the console. All right. Good job, folks. Some other examples of the do loop. If you are in a do forever situation where you have a loop and you're just looping forever, you can leave the loop with the leave command, and you can provide a condition that will cause the loop to terminate. In this case, if I is greater than 10, we're going to leave. Now we are also incrementing I manually in the loop. And this is why we get 11 cats, because our check for I greater than 10 is after the increment. So we're going to get 11 lines displayed. If we want to skip a loop iteration, we can use the iterate command. And what this will do is this will go back to the top of the loop to reevaluate the do condition. So in this case, we're doing I equals 1 to 10. If I equals 4, we're going to iterate, and then we display our cats. So what this has the capability of doing is skipping an iteration of the loop, and that's exactly what happens here. We skipped 4. A do forever loop needs a leave or an exit to terminate. A forever loop will increment a counter without end. In this case, we don't have a terminating counter here. We just have I equals 1, and this will very happily count I and display the values forever and ever. A repetitive loop and a conditional loop can be combined. So in this case, we're doing I equals 1 to 10, but we have an additional condition until name is not equal James. So as we're going through the loop, if the value of name changes to something else other than James, then we will terminate the loop at that time. Okay, we're going to talk about functions and subroutines. Functions and subroutines are both code that is used to perform repetitive tasks. This has the capability of eliminating repeat logic in your code. So if you have a set of code that you're running multiple times, and it could appear multiple places in the program, just put it in a function or subroutine. That makes the code much easier to read. A function or a subroutine can be internal or external, meaning it could be part of the program or outside of the program. 0 or more parameters can be passed. A function must return a value, whereas a subroutine can return a value, but it is not required to. Here are some examples. On the left-hand side, we are collecting arguments from the command line. In this case, num1, num2. In the next statement, we are calling a function called add them and passing those arguments, num1, num2, as parameters to the function. And the result is going to be put into the variable sum, and then we're going to display sum. Add them, here is the label for add them, add them, and with the procedure clause after it. We're getting the arguments that were passed in variables called val1 and val2. We are adding them together into a variable called res and then returning res. So when this function returns, the value is going to be put into the variable sum in the caller, and then we're going to display the value. So what happens is our code is example 7. We're passing 2 values, 2 and 2, and the sum is 4, and we have verified that REXX can add 2 and 2. The next example is being used as a subroutine. A subroutine is initiated with the call command in REXX. We call the subroutine, and pass the parameters similarly to how we did with the function, but without the parentheses. And the subroutine in this case works very similarly, and the sum is calculated here in the subroutine, and we're going to return the value sum. Now, in a subroutine, the result, the value that is returned is always in a variable called result in the caller. That's why we're displaying a result instead of sum. In the third example, we have removed the capability or the fact that there's a procedure directive here. Now, in the first two examples, it's important to note that the variable pool of the caller and the variable pool of the subroutine or function are separate, which means I didn't do it in these. It probably would have been a better example, which means that you can reuse variable names and they do not affect the caller or the subroutine. So they're separate entities. In the third example, the variable pool is global since we don't have this procedure clause on the in the label. So we can pass the parameters, just call the subroutine and display sum because the sum in the subroutine is also a global variable, as is the parameters that were passed to the function, the subroutine, I should say. So this is a very good distinction to know about where variables are either local or global. And all that stuff that I just talked about is right here on this slide. All the variables from the caller are available to the function by default. If a variable is changed in the function or subroutine is available to the caller. That is without the procedure component in the label. Variable isolation can be achieved using the procedure keyword after the label. The code is, so if you're using variable isolation, you can have visibility to the caller's variables with the expose keyword after procedure. So in this case, I have a procedure here and I'm exposing three variables, and these three variables are the caller's variables that you are being exposed to use in your function or subroutine. Kind of very subtle differences, but important to note. Okay, we're going to talk about string functions. REXX has a good set of string functions that can be used to manage sets of characters. Length, right, left, strip, which will remove characters from the beginning or end of a string. The space function, which will remove sets of characters between fields in the string, between words in the string, I should say. The substring function, which will return a portion of the string. Center, which will center a string within a certain set of certain length of space, characters, I should say. And copies, which will return a number of copies of a string. I'm going to go through a few examples here. So for length, we have a variable called name. Name is assigned to the literal John, and we're going to display a literal name length and use the length function to return the length of name. And the name length will be 4 because there are 4 characters in John. The right function returns the right number of characters from a string. And the number is specified here in the second parameter of the right function. So we're assigning New York to a variable called state, and displaying the literal last four, and then right state 4, which will return and display the right 4 characters of New York, which is just York. Pad comes into play when the string is shorter than the count. So in this case, state is Ohio, and we're going to display the right 6 characters of state with a pad character of a period. So what this does is this, since Ohio is only 4 characters long, the pad character is used to pad the first 2 characters of the result. So what this also allows you to do is to justify a value inside of a string. If you don't specify a pad character, the default is a blank. And in this, if we had not specified the pad character, there would be 2 blanks here. The same works for the left function. It would work very similarly, except that the value would be left justified. The strip function allows you to eliminate characters from the beginning or the end of a string. And in this case, we have a string called a string of Florida with spaces on the end of it assigned to a variable called state. Now I'm doing 2 different say clauses here, and I am putting a character on each side of the result so we can see what the result of the strip is. So if we just display state, we're going to see the spaces at the end of Florida. If we strip state, we're going to see just Florida by itself. REXX also provides for word handling. What this means is words in a string. Think of a sentence or something that that has multiple words in it, and a word is a set of characters delineated with spaces. And the word functions allow us to count the number of words in a string, to get the length of the nth word, like the 3rd word in the string, to get the position of a word in the string. That's what word pos allows you to do. Word index will return the character position of the nth word in the string. So if you want to see what position, what character location the word hello is in, it will return that. And you can also just return the nth word of a string. So if I want to see the 3rd word of the string, it will return that value. Some examples. We have a string, now is the time, and if we just specify that we want the 3rd word in the string, it is going to return the, since the is the 3rd word in the string. Word index returns the character position in the string of the word that you're looking for. So in this case, I'm looking, I want the word index of the 3rd word in the string, and the 3rd word is the, and it is at position 8 in the string. If I want to search a string for a specific word, I would use word pos. And word pos, you specify the word that you're looking for and then the name of the string. And in this case, it is going to return 3 because the is the 3rd word in this string. If it does not find the, it will return 0. All right, data type returns the data type of a variable. That means whether it's numeric or character. It returns also, it can return true or false if the data type matches the second parameter. So in this example, we're providing two parameters and we're checking to see if value is an n data type. And looking at the table, n is a number. So if the value is, if the value variable is numeric, meaning it is true, then we display it is a number. If it is not, then nothing will happen based on this code sample. So these are the different types of variables that you can look for with the data type function. Very helpful when you are trying to determine if the value is numeric for future use inside of a program, so that like calculations don't fail or things of that nature because the data entered was incorrect for its for the usage. The select clause is very similar to a switch or case statement in other languages. Otherwise, a keyword otherwise is required and no op can be used. I have an example of that. Next, select is used to evaluate multiple expressions. So this is very helpful if you have a situation where you're looking at a lot of different expressions and a nested if would be would would not work well. Select is much easier to read in cases like that. So here is an example. We are passing an argument to this exec called age, and the select clause has two conditions that it's checking. If age is less than 50, or if age is greater than or equal to 50. If it's less than 50, we're going to display full warranty. If it's greater than or equal to 50, 50, I should say, it is time to be renewed. Lisa, I see your comment there. Good job. And the otherwise clause has a no-op, which means that if there was a condition that did not meet, or if the condition evaluation did not meet any of these when statements, otherwise would be executed. And in this case, it's just a no-op because any value should fall into these two conditions. So here are some examples. I'm going to pass it the value 38. I get full warranty because the value 38 is less than 50. And if I pass it 51, I get the response time to renew. So that's a general idea of how select works. RC, the variable RC, is a special REXX variable that contains the return code of the host command, of a host command, I should say. So if I issue the command cp query mate4, and I'm going to display the result of that query, the second line here is the result of a query. The first line is displayed by CP as a result of the query command. The exit command can be used to terminate a REXX program and pass back a return code. So if you're running through your program and you want to pass a return code back to the caller, you can use exit or return. That works as well with a value. It doesn't have to be a literal value. This can be a variable to pass back a return code to the caller. It is always good practice to code exit at the logical end of the program so that you know where the end of the program is. Because if you have a bunch of subroutines later on in the program, and if you don't have an exit or a return, REXX will very happily fall through the logical end and start trying to execute those functions or subroutines. Signal with a label name after it transfers control to that label. It works very much like goto in other languages. So in this case, we have signal my routine. When execution gets to the signal, control will be transferred to the my routine label and it will start executing code at that point. Signal is much better used to trap errors in a program. So in this case, we have an on-off switch as part of the signal syntax, and condition is one of the conditions listed here. So there are a number of them that you can use. I typically use signal on syntax at the beginning of my program to catch potential interpretation errors. And then there's a routine that I execute called syntax that will display some debugging information. Trapping errors in a program using signal allows the use of special REXX variables. Sig_L is the line number of the error. Source line is the actual line in the program that returned that caused the error. And error text is the REXX error message that would be generated because of that error. And here I have an example. So signal on syntax allows us to catch an interpretation error. This could be bad data. It could be a number of different ways, a number of different reasons why syntax would be called. And the syntax routine is later on in the program. And what we have here is I always preserve the return code from the signal, say error text, and the error text takes the return code and displays the actual error message, in this case, bad arithmetic conversion. The next line displays the actual line number on line and then the line number sig_L, and that's what the second line in this output provides for. And the third display is the actual source line, and you pass it the line number variable, and then you get the actual source line. So the reason syntax was called in this case is because based on this program code, A is uninitialized, and we're trying to add 1 to an uninitialized variable. So that's what would cause this error. A host command is a command that you would typically enter on the command line using address command or address CMS, depending upon what type of command it is. Address command is very specific, which passes the parameter to CP or CMS without searching. And searching means searching through the file modes. Address is important in multiple command environments. So if you are writing an xedit macro or writing some CGI code, whatever the case is, it's very important to understand what environment you are in and what environment to indicate as you're passing that you're passing commands to. We'll talk some more about this in the next REXX class later this month. A host command is recognized when a clause is not a comment, not a label, not an assignment, and does not begin with a REXX keyword. It is assumed to be a host command, and it is passed to whatever command environment is active at that time. Tracing produces diagnostic information about the program. There are a number of different trace points available to the program. What I typically use is the intermediate trace, because that produces a lot of detail. especially if if your program is doing a lot of looping and looking at values. If I need to trace, I will typically use immediate. S is good to check code structure. I is good for very comprehensive tracing. It can be very voluminous, produce a lot of output. And L is good to see which routines are called. So when you're reading a trace, the trace output produces messages that start with these sets of characters. And we will talk about this when we look at trace output. Tracing also, the intermediate trace produces a number of trace tags, indicating the content of a variable, whether it's a literal, function call, result of an operation, or the compound name of a compound variable after substitution. So you get a lot of output when you're looking at an intermediate trace. So here's an example with our old friend, the age test. I have trace I at the beginning of the program, which will show me everything in the program, and it's exactly the same. So when we run the program, and we're going to pass it 44 in this case, we see that the argument, and this indicates that a REXX clause is being displayed. So the argument is age, and the three greater than signs indicate the result of an expression. If I go back to the previous slide. So the result of an expression in this case is 44. Another REXX clause is my select clause. Another REXX clause when age less than 50. What it's displaying here is the variable, which is the age variable. The content is 44. A literal, and the literal is the value that's being compared to in this case, and that is 50. And the result is 1. And 1 means that 44 is less than 50. It evaluated to true. So that's what the 1 indicates. Another REXX clause, then another REXX clause, full warranty, and the literal full warranty is indicated as being the result of a say clause. And then here's the display, full warranty. So in a nutshell, that's how trace works. Very comprehensive tracing is available using that trace I function. And there's lots of other options as well. All right, we're going to talk a little bit about input and output. Line input can be used with the line in function. The line in function takes parameters. The first parameter is the name of the stream. In this case, the stream is a file name. The line is the line number that is being read. If you're reading from the beginning of the file, this would probably be 1. And count is the number of lines that you want to read. So if you only want to read 10 lines of a file, you could certainly do that. Line in by itself is equivalent to a poll function, which reads input from the stack or the console. In CMS, we very rarely use line input and line output. There's also a line output function because there are much easier ways to get input and output to a program. And the CMS pipeline session next, and the second REXX class later this month, we'll talk in more detail about how we easier ways to get input and output. Line out, very similarly, the name of the string, the data to be written, which is a string, it could be a string variable itself, and oops, this is wrong. I didn't even look at this. Line out returns 0 if it is successful, 1 if it is not. And line out with the name by itself is equivalent to closing the file. I didn't even look at this because we don't even rarely, we don't use this. These are more functions that you would use on Windows and Linux. Um, uh, we don't really use these in CMS. Lines by itself returns the number of lines left in the stream. So if we have a set of code that does a do until lines, and in this case, we're specifying a stream, which is examp11 exec, do until the number of lines remaining is 0, we're going to display the lines in the file. So what we are basically doing is displaying our own program, because examp11 is the name of the exec, and it just displays the contents of the exec. There are also other um, input-output functions, character in, character out, and the characters function. Also rarely used rarely used on VM, because VM is not really a character-based stream kind of platform. It's more record-based. So this is more relevant to Windows and Linux. The value function returns the value of a variable, and the variable has to be in quotes. So if we specify value count, it's going to return the contents of the count variable as part of the function. If we specify a value after, as the second parameter of the value function, it will return the value of the variable and then set it to the value in the second parameter. So count might be 3. It will return 3 and set the value to 4, for example. If the variable is not initialized, count is just returned, the literal count is just returned in uppercase, like REXX would typically do. Translate is a extremely powerful capability. And what this provides for is, and it accepts 4 parameters. What this provides for is the ability to translate a string from with a set of input characters, that's the input table, and the set of to the set of output characters. So it's going to go backwards through the parameters. Table I is a string of source characters. Table O is a string of target characters. Translate by itself, like in the first example, would just translate the string to uppercase. The next translate function, here we have the input ABBC. The input table is just a single character, a lowercase b. The output table is in ampersand. And what this is going to do is it's going to translate all the b's to ampersands in the entire string. So, and that's exactly what the output looks like. The 2 b's in the middle are translated to ampersands. In the third example, it's going to translate EC, the EC characters, to 1 and 2 respectively. So E will be translated to 1, C will be translated to 2, and the result shows that the E was in the 5th position, it's translated to 1. C being in the 3rd position, it was translated to a 2. In the last example, we have added a pad character. So we have an input translate table that is longer than our output translate table. So what's going to happen is the excess characters, the remaining characters, will be translated to the pad character. So in this case, A is going to get translated to 1, B will get translated to 2, and C and D will be filled with the pad characters. So if we look at the output, our A was translated to 1, our B was translated to 2, C and D are now our pad characters, and E and F were left alone. Very powerful capabilities with this translate function. Parse is a very powerful mechanism that allows you to extract values from a string. We were exposed to parse briefly when we talked about accepting input from either the command line or the console with parse arg, parse put, parse pull, I should say. And those options are listed here, parse arg, parse pull. The idea behind parsing characters is you specify a value. Here's the value clause. And you specify an expression, which could be a variable, or a variable itself, and give it the variable name. And the template list is how the items are going to be parsed. And we are going to discuss it all right here. And here's our parse value, specifying an expression with the template. The template is how you're going to parse the value. The same thing with the variable. So you can specify a variable name after parse var and how you want to parse that variable. Here are some examples. In the first example on the left-hand side, we are going to parse the result of a function. So 1, 2 is a function inside the program. And the value of 1, 2 is going to be returned back to the parse command, and we are going to be able to parse out the values that are returned into our variables val1 and val2. So 1, 2 will be executed. It will return the values 1 and 2. 1 will be assigned to val1. The number 2 will be assigned to val2, and that is what is going to be displayed. I don't have an example of the output, but it would just be 1 and 2. In the next example, we are going to call a function called 123, and the result will be put into X. So when we call the function, here's the function down here, it is going to return the values 1, 2, 3. It's just a string of characters. The fact that they're numbers is not important in this case. So 1, 2, 3 will be assigned to X, and we're going to parse the variable X and with val1 and val2 with a period in the middle. The period is a placeholder. It is a part of the result that you want to throw away. So we don't care about the second word in the result. And what this really means is the number 2 in the result is going to be thrown away. Val1 is going to be 1. Val2 is going to be 3. And that's what's going to be displayed. Here's an example of parse that might be a little more relevant. We're going to get the time function, parse the result of the time function, and parse it out into its constituent components. So in this case, hours, HH, minutes, MM, and SS being seconds. And we have a literal in between hours and minutes, which is the colon that comes back from the time function as the time display. We don't care about the colons. We're just going to throw those away. We just want the numeric values. So in this case, here are example 15. We are going to execute that command, and then we're just going to display hours, minutes, seconds, and put dashes in between them, just as a different way to display the values. And here is the result when we run example 15. So in this case, we're breaking a value up, in this case, the result of a function, and throwing away the parts that we don't want with the literal, since these colons appear in the result. Here are some additional examples of parse. In this case, with positional parsing. So you can also walk through a string, characters at a time, looking for items to parse. So in this case, we're doing something very similar, parsing the value of time with HH, and HH is everything that is the first two characters, I should say, are put into HH. That's what this indicates. So HH gets the value of 10. We have a throwaway character. That's what this period indicates. One and then incrementing one character. So we're going to throw away the colon and increment our pointer to the 15. And then two characters later, we're going to go two more characters and put whatever it was in those two characters into MM. So, oops, I'm down here. So here is the 15 value that will go into MM. And this goes on until the end of the string. The result should be HH contains 10, MM contains 15, and SS contains 30. That's the end result of what this will provide for us. Parse source allows you to get information about the environment and the source program. So in my example, I'm doing parse source a couple of times. And parse source, and I'm just going to put the whole thing into a variable called vals, and I'm going to display vals. The second line here that starts with CMS command, that is the output from parse source. And I'm going to parse source again with the file name, file type, file mode, but I'm throwing away the first two words and everything after the file mode. So that means I'm going to throw away CMS, I'm going to throw away command, and these three values, example 16, exec A1, will be put into these variables, and everything else is going to be thrown away. And then I display the values, and that's what comes out as the result. This is very handy to determine where your program is running, if it was called from something else, and there's a lot of different ways you could use this. Parse external gets data from the terminal input buffer. So this is very much like getting data from the from the VM read. It's going to do a VM read and allow you to enter data, but it leaves the program stack intact. So this does not touch the program stack. So if you're using the stack for something and want to do some terminal input real quick, parse external is the way to do it. This also allows a REXX program to retrieve data that was passed to it when a machine is X autologged. So what you could do is you could have a service machine that is running that accepts input from someplace else through the X autolog process. And on that X autolog command, when you're bringing up a virtual machine, you can pass data to it using or get data from it, I should say, using parse external. Okay, homework time. All students have access to our ZVM system with their own CMS virtual machine. There is homework, and homework will be checked. And this will be a fun task for a lot of you, I'm sure. The homework is to create a REXX program to play the game tic-tac-toe. You think it's easy, but sometimes not. So the tic-tac-toe rules, it is a 3x3 grid of numbered squares. The player at the keyboard plays against the program. The players take turns, display the grid at the start of, I should say after each turn. So after you play or after the computer plays, display the grid. Each player selects a square to play by number. Since there's 9 squares, the numbers have to be 1 through 9. A previously selected square cannot be played again, and the player puts any player that puts their pieces in 3 squares in a straight line, up, down, or diagonally, is the winner. Send an email to homework when you're done. We will be checking your homework, and send your program to the homework user with this command: send file, file ID, which is file name, file type, file mode, homework, and the homework user will be looking at the results of the program. All right, I am open for questions. How are we doing on the chat?
Chat is all caught up so far.
Awesome. Thank you, James, and whoever else was responding.
And just a real quick update for those that have to use their own ZVM system for your homework assignments. Just send the email with the file attached to it that you completed.
All right, well, thank you, Rich. We're going to go ahead and take a 10-minute break, so I will be setting a timer and we will see you back here in 10 minutes.